Hey guys, I know you already completed the review originally done in class. This is just a few extra questions in case you have any more continuing questions or need help both on the highlighting techniques that I'll be offered as a bonus on tomorrow's test or how to change functions based on translations. So let's start with the first one. Okay, I see a lot of words and I don't want to get lost, so I'm going to use my stop, slow, go technique. So I'm going to stop and just look at my question. Anything that looks important, I'm going to highlight it. So Glenda's running a restaurant and buying food for her best friend's birthday party. She's trying to decide whether it's better to rent a room at Buca di Beppo for $88 and get the better menu that costs $45 per person, or if she should rent a room at Seasons 52 for $123 and get the menu that costs $40 per person. Which best describes the change that will occur when comparing Seasons 52 to Buca di Beppo? I know I'm just like butchering that name. Okay, so I have first stopped, but I need to dump every piece of information that I know. So this is an $88. That's a one-time fee. Okay, which also means it's our y-intercept or our b value. Okay, this $45 per person, the per person tells me that it's going to be our slope, which means I'm going to have 45x. It's the rate of change. Okay, it determines the steepness. Okay, this 123 is our second y-intercept. Sorry, I'm trying to write without covering everything up. Or one-time fee. Okay, it's our b value. And this $40 per person is the second slope. So we would have 40x. It's your m, your rate of change. And it's the per person. Okay, so I can dump two questions just from what I've highlighted. We've got y equals 88 plus the 45x, and then y equals 123 plus 40x. Okay, then I'm going to slow down and make sure I know what the actual question is. So which best describes the changes that will occur when comparing Seasons 52 and Buca di Beppo? So what changes will occur? So we're going to go ahead and go on to the answer choices and look for the differences. So this one's talking about the cost per person increases by 5 and the cost of renting the room decreased by 35. This one says the cost per person decreased by 5 and the cost of renting the room increased by 35. So really the numbers aren't changing. All that's changing is increase, decrease, decrease, increase. This is decreased by 5, cost of renting the room decreased by 35, increases by 5, increased by 35. So I'm going to look at my two equations and see which part's different. Well, the 88 is different than the 123. And the 45 is different than the 40. So what does that mean to me? This part is increasing, so increasing, which was also the cost of the room. And this 45 to 40 is decreasing. And that's the per, or the slope. Okay, well we know one thing is increasing, one thing is decreasing. So if they're both increasing or both decreasing, we can eliminate those. Now I've got to match them up. So the cost per person is my slope, that's my per, which I've already dumped right here, and that's decreasing. This is the only one that says that it's decreasing. But let's make sure the other one's correct. And then the cost of renting the room, which is this part, okay, is increasing by 35. If I typed in my calculator 88 plus 35, that is 123. So the answer is B. So we're going to ask you to use those highlighting techniques on 3 questions on your test to get bonus points. You'll get 2 points for every question you have time to do. Okay, so let's go ahead and go on now that we've used our highlighting techniques. So let's look at question 2. Given the linear function y equals y equals 5, parentheses x plus 18, write the function that represents a translation of 5 units to the left. Okay, guys, you can use your highlighting techniques on even short problems like this. So for example, okay, my equation's important, and we're writing the function that represents a translation of 5 to the left. And I'm going to dump. Okay, this 5 right here is the slope. This plus 18, since it's inside the parentheses next to the x, it's the opposite, so it's going to be left 18. Okay, and over here, to go 5 units to the left, we're going to add, because it's the opposite, 5. So I'm going to take this equation that I'm starting with, this y equals 5 parentheses x plus 18, and I'm going to be adding some more inside the parentheses. So my final equation is going to be y equals 5 parentheses x plus, what's 18 plus 5? 23. And that is your final equation. So you have to actually make the change to the original. It didn't tell us it went up or down any, so we're not going to change the y-intercept. And it didn't tell us that it stretched or compressed, so I'm not going to change the slope. Those two things stay the same. So moving on to number 3. Given the linear function below, fill in the blanks to describe what changes occur when you compare y2 to y1. Okay, so looking at these, this part, this part, this part, this part. Okay, so the 2 is the slope. Okay, that minus 7 is the y-intercept. 6 is the slope. The minus 9 is the y-intercept. That's the point 0, negative 9. That's the point 0, negative 7. I know that 2 is steeper than the parent function. So is 6. Because the larger the number, the steeper it gets. Okay? So when I'm comparing them, the slope of y2, so we're looking at this one, is blank compared to y1. Hey, what did I say? It's steeper. 6 is greater than 2, so it's steeper compared to y1. We call this a vertical stretch. Okay? So now we're talking about y-intercept. The y-intercept of y2, okay, so this one, which is talking about that negative 9, is blank to y1. So this one's at 0, negative 9. This one's at 0, negative 7. So this one is below that one. So this is a vertical shift for translation down. Okay, maybe you're not very good at equations. When it comes to the test, let's look at the visual. Let's type in the equations into my calculator and see what's happening. So I'm going to go to y equals. The first equation they gave us was 2x minus 7. The second equation is 6x minus 9. Okay? So that's y1. That's y2. So I can see, just looking at it, knowing nothing about my equations, y2 is way steeper than y1. Okay? y2 is also down there. It's lower. But what about the x-intercepts? So y2, the x-intercept was right here. y1, the x-intercept's over here. So the x-intercept is further left. Maybe you can't tell from the graph. You could also look on the table. we're looking for where the y values are 0. So for y1, it's going to be somewhere between 3 and 4. So let's just say 3.5 comma 0. y2 is going to be somewhere right here's where the sign changes, so somewhere between 1 and 2. So 1.5 comma 0. So 1.5 for an x-intercept is further left. So this is going to be a horizontal translation. Left. Okay, so looking at number 4. Given the function f of x equals negative 5x plus 26, write an equation that is a vertical compression. Okay, what does vertical compression mean? That means we're decreasing the slope. Well, which part is the slope? It's the number in front of x. So we're talking about that negative 5. Now, an important thing to remember is that we're not talking about a 5 per se. We're talking, a negative 5. We're just talking about that 5. The negative deals with something else entirely. So we need to decrease that actual number. So a vertical compression could be f of x equals, it could be anything smaller than 5. So we could say negative 2x plus 26. Okay, a vertical stretch means you're increasing the slope. Again, we're not looking at the negative, we're just looking at the 5, the number in front of the x. So we could pick any number that's greater than 5. Let's do 10. A vertical shift up. Okay, now we're affecting the y-intercept, and we're going to increase the y-intercept to make it go up. So this is the 26. We're not changing the slope, but we're increasing 26. You could increase it to any number you wanted. I'm just going to do 50 because I like my 5s and my 10s. Vertical shift down. So now we're decreasing the y-intercept. So we need something smaller than 26. So we keep everything else the same. We need something smaller than 26. Let's just say 10. So it doesn't necessarily have to be negative. It has to be smaller than what you're comparing it to, or lower than what you're comparing it to. Now, if you wanted to put a negative number for that y-intercept, that's fine too, because negative 12 is lower than a positive 26. Just be careful when you're doing that with your slopes, because you're not considering that negative. You're just looking at that actual number. Okay, last one I want to look at. If f of x is located 15 units above g of x. Okay, like I said, I'm a visual person, so I'm just going to draw a picture. So f of x is located 15 above. So here's my f of x. Here's my g of x. I don't know what the actual numbers are. I just know that this is 15 units between them, and f of x is on top. Okay? So this f of x is at 3x plus 20, and we want to know where g of x would be. They didn't change the slope. They just want to know what this new value is for g of x. So they want to know where this one is. So even though they told me above, am I going to be adding to get g of x? No, g of x is below the f of x. So instead of adding 15 units just because it's above, we're going to be subtracting that 15 units from the y-intercept. So draw yourself a picture. Make sure you understand which one is on top. So we've started at this one, and we want to get down here. So we're going to subtract 15. So our value of c, so our whole equation would be g of x equals 3x plus 5. So just the value of c is 5. Okay, guys, make sure to use your highlighting techniques tomorrow. Get a good night's sleep. Use your calculator cheat sheet. Use your calculator, period. And I know y'all will do great.